Okay, so the final topic of section 4.2 is going to be the plot of cotangent. So let's recall that cotangent is the reciprocal to tangent. So cotangent of theta is actually cosine of theta over sine of theta. So what I will do, let's note, if I have a theta versus tangent of theta versus cotangent of theta plot, let's see what we have here. So if theta is 0 radians, tangent of 0, recall, was 0. So the reciprocal to 0, thou shalt not divide by 0, is undefined. Let's have theta being pi over 4 radians, or 45 degrees, and we know that tangent of pi over 4 is 1. So the reciprocal to 1 is 1. Maybe I'll do this in blue. Now let's go on to pi over 2. And tangent of pi over 2 does not exist because it's sine over cosine, meaning I'm dividing by 0. But the reciprocal does exist, and it is 0. In quadrant 2, we have the 45 degree reference angle, 3 pi over 4, and tangent in quadrant 2 was -1, so his reciprocal, cotangent, is also -1. Now going to pi units, pi radians. Tangent of pi radians was 0, so the reciprocal is not allowed, which means there'll be a vertical asymptote there. Okay, into quadrant 3, add 5 pi over 4. A negative divided by a negative gave us a +1 for tangent, hence the reciprocal for cotangent is also +1. Going down to 3 pi over 2, 270. We have that tangent was not defined because we were dividing by 0. So the reciprocal, of course, will be 0. Okay, now going into quadrant 4 at 7 pi over 4. We had that tangent was -1, so is his reciprocal. And last but not least, let's go full circle. So 2 pi. And we're right back to 0 for tangent and undefined for cotangent. Okay, so let's go ahead and consider the graph. So consider the graph of f of theta is equal to simply cotangent of theta without any augmentations. And in fact, let me color code this to blue. Okay, pardon me. So theta versus f of theta coordinate axes. Let's break the horizontal axis into 4 parts. So we have 1, 2, 3, 4 quadrants going to the right, and 1, 2, 3, 4 quadrants going to the left. Let's go to 1 and -1. So first quadrant is 90 pi over 2, then pi, then 3 pi over 2, and 2 pi. Going backwards will be -pi over 2, -pi, -3 pi over 2, and -2 pi. So I'm going to put the tick marks at the 45 degree reference angles. So going forward, that would be pi over 4, 3 pi over 4, 5 pi over 4, and finally 7 pi over 4. but I'm just going to simply mark the midpoints going to the left. Okay, so now let's see what happens. Cotangent of 0 does not exist, meaning I'm dividing by 0. So therefore, that is a vertical asymptote to the graph of cotangent at 0 radians. Now, let's go on to cotangent of pi over 4. And it looks like it's positive 1. Cotangent of pi over 2 is 0. And cotangent of 3 pi over 4 is negative 1. And then cotangent of pi does not exist again. Hence, there is a vertical asymptote at pi. And at 5 pi over 4, I'm back to positive 1 for cotangent. Then at 3 pi over 2, I'm down to 0. And at 7 pi over 4, I'm down to negative 1. And full circle, I have a does not exist, or division by 0, vertical asymptote. Okay, so going backwards, if I note here what's going on, it looks like there's a vertical asymptote every time sine, or the denominator, is 0. So every pi units, there's a vertical asymptote going forward and backwards infinitely. Okay. I know that cotangent is 0 whenever cosine is 0. So that would be at pi over 2 and 3 pi over 2. And then it looks like that this has a period of pi, right? So this is the graph of cotangent of theta. And it repeats every 2 quadrants, which is a period of pi for standard quadrants, right? Okay, so this does look kind of like tangent. However, it's going downhill in reading direction. So let's note, what are the restrictions to the domain? Cotangent has sine of theta in the denominator. So the domain will be all values of theta for which sine is non-zero. So therefore, theta cannot be equal to those values that lie on the x-axis. So that would be any integer multiple of pi, positive and negative. Those are the exclusions to the domain. The range, of course, much like tangent, is all real numbers. There is no interruption to the range. It goes infinitely downward and infinitely upward without any breaks. Okay, so hopefully everyone's okay with that. Pardon the heater. I was cold, so I turned it on. And of course, everything in this house makes so much noise. Okay, moving on. So now let's recall what I said in the last section. So let's recall. The period for tangent P is equal to pi. Well, the period for cotangent is also pi, right? I can see that. Because that is the distance between any two asymptotes. That is the distance between repetitions is pi units. Okay, so therefore, maybe I should make this recall a different color because I would like to recall my theorem. So let's make this red. And now let's recall the theorem. I'll just write it again. So theorem for f of theta being equal to a times cotangent of n theta the number 1 amplitude is equal to the absolute value, because it's a distance, of the coefficient a. And number 2, the period is going to be pi over the absolute value of n, and that, of course, is for 2 quadrants, or tick marks. Okay, so for example, let's go ahead and plot f of theta is equal to, so I plotted normal cotangent here. Let's do, 2 cotangent of 7 theta, just to kick it up a notch. Okay, so the amplitude, A, is 2. That means it stretches vertically by a factor of 2. I know that my period is going to be pi divided by 7. But remember, that's for 2 quadrants, right? 2 quadrants. Okay, so what do we mean by that? Well, let's see. Theta versus f of theta coordinate axes. Okay, so theta and f of theta. Let's go up 1, 2. Let's make them small. Let's do 1, 2, 3, 4 tick marks to the right, and 1, 2, 3, 4 tick marks to the left. Normally, for periods is 2 pi, but I'm dividing by 7. So let's take each quadrant, pi over 2, pi, and 3 pi over 2, and divide it by the coefficient of theta inside the argument, 7. So, is it true that 2 quadrants, or tick marks, is indeed pi over 7? Well, is this distance pi over 7? And it is. Okay, so we're set. Okay, so now going backwards, that would correspond to minus pi over 14, minus pi over 7, minus 3 pi over 14, and last but not least, minus 2 pi over 7. Okay, so for cotangent, I know that the asymptotes start on the y-axis and are every 2 quadrants. So the asymptotes for cotangent, unlike tangent, do start on the y-axis and are every 2 quadrants. And I use quadrants in quotations because, of course, these have been augmented by the coefficient aside theta. Okay. Now, much like tangent, cotangent is 0 smack dab in between each of the 2 vertical asymptotes. Now, usually it would be 1 at the 45-degree reference angles, which is halfway through each quadrant. However, this is now twice as tall, and I know cotangent goes downhill in reading direction. So the first period for cotangent will look something like so, with an amplitude of 2, that is, it's twice as tall. And an augmented period now of repetition every pi over 7 units as opposed to pi. Okay, and we just repeat. Downhill, cotangent goes downhill and has a vertical asymptote on the y-axis. Okay, however, for this graph, we note that the domain is all values of theta, save for those values that are the vertical asymptotes, which are at pi over 7. And it looks like the difference is oh, actually, we're on the at 0, so pi over 7 times k, where k is any integer. So they are pi over 7 units apart, each of those. And once again, the range is all real numbers. Okay, so let's go ahead. Let me actually underline. Hopefully we know what we're plotting here. Okay, so shall we do one more for good measure? Just like we did for tangent. So for example, let's plot f of theta is equal to minus, let's do 1 tangent of, what should I do? I haven't done like 11. That sounds good. 11. And why am I plotting tangent? I already did that. I can't talk and write at the same time. So let's do cotangent of 11 theta. So in this case, we have that the amplitude is equal to 1. The period, which of course is 2 quadrants, will be pi divided by the coefficient of theta, which in this case is 11. And remember, that's for 2 quadrants. 2 quadrants, whatever that may mean. And notice we've got this minus sign, which means it's got an x-axis reflection. Okay, so here we go. Theta versus f of theta coordinate axes. So vertical and horizontal. So theta, once again, the heater is being very annoying. Okay, there it goes. So 1, 2, 3, 4 quadrants to the right, and 1, 2, 3, 4 quadrants to the left. Amplitude of 1. Okay, so normally 4 tick marks is 2 pi. However, I'm dividing by the coefficient of theta, which is 11. So all of my quadrants, pi over 2, pi, and 3 pi over 2 are going to be divided by the coefficient of theta, in this case 11. And look, it is true that the length of 2 tick marks or quadrants now becomes pi over 11, as it should. So going backwards, these will correspond to minus pi over 22, negative pi over 11, negative 3 pi over 22, and last but not least, negative 2 pi over 11. Okay, cotangent has his asymptotes along the y-axis and every 2 quadrants thereafter. And similarly, going backwards, so every 2 quadrants. Oops, that doesn't look very nice. Okay, I know that cotangent will be 0 at the midpoint. I know that if I were to plot normal cotangent, he would go downhill in reading direction. So let me put the tick marks for the 45-degree reference angles in each quadrant. So normally, cotangent goes downhill. However, for this graph, since it's reflected, about the x-axis, let's see what happens. Okay, so what was once -1 is now +1 and vice versa. in each period. So what happens is now we get a graph going uphill in reading direction, which looks very similar to tangent. The only difference now is that tangent had his asymptotes at pi/2, or the first quadrant, and the third quadrant, whereas cotangent has them at 0 and pi, or the second quadrant. Okay, so this is a graph of minus cotangent of 11 theta, and I hope this makes sense to everyone.